All right, in this lesson, we are going to solve trig equations. So let's say I have the equation sine x equals root 3 over 2, and I want to solve this. So I want to find all angles x that are going to make this equation true. Now, there's many angles, in fact, there's infinitely many angles that are going to make this equation true, so I want to try to find all of them. Okay, so I'm going to start by looking at just one rotation of a circle, so just between 0 and 360 degrees. Okay, and one thing that is going to help us with this is thinking about in which quadrants are the trig functions positive and negative. And there's actually an acronym that can help us with this. So let me draw out my quadrant here. Uh-oh. There we go. Okay, so I'm going to have an A, S, T, C. And the words that represent those is all students take calculus. Okay, there's my acronym. And what this, what I'm saying here is in the first quadrant, we have all trig functions are positive. So A for all trig functions are positive. In the second quadrant, sine is positive, which also means cosecant would be positive. In the third quadrant, tangent is positive, which also means cotangent is positive. All other trig functions are negative in quadrant 3. And in quadrant 4, cosine is the only one that's positive, and secant, of course. Okay, so having that acronym, all students take calculus, can help us remember in which quadrants are the trig functions positive and negative. Okay, so here I have sine of my angle is equal to a positive root 3 over 2. So I want to look at the two quadrants where sine is positive, and that's going to be in quadrant 1 and quadrant 2. Okay, so I'm going to have a couple angles in quadrant 1 and 2. So I'm going to draw an angle here in quadrant 1. I'll go ahead and draw the angle here in quadrant 2. Okay, I know that sine is opposite over hypotenuse. So my opposite side is going to be root 3, and my hypotenuse is 1. That would make my bottom side, or hypotenuse is 2, that makes my bottom side equal to 1. Okay, so my angle, my reference angle, is going to be my 60-degree angle. Now, over in the second quadrant, it has the same reference angle as 60 degrees because my triangle is going to be set up the same. The one, I guess, would be negative in quadrant 2. But I don't want just that 60-degree angle. I actually want this obtuse angle, which I can do 180 minus 60 to get 120. Okay, so I know two of my solutions are 60 degrees is a solution, 120 degrees is a solution. Oh, let me just write that separate like this. 120 degrees is the solution, and I could go all the way around the circle as many times as I want and continue to get more solutions. So like I could go around the circle all the way over here and stop. That's going to be a solution. I could stop over here at the 20-degree angle. That's a solution. I could go 1, 2, stop there. It's another solution. Here's another solution. I could also go in the negative direction. So I could stop here. That's a solution. I could stop there. That's a solution. So the way we can represent that is we want to take these two angles and we can add as many multiples of a full rotation as we want. So I can add a full rotation is 360, so any multiple of that. So I'll do 360k. actually doesn't matter where you write the degree symbol. I don't like how that looks, so I'm going to write that. And so I'm going to put plus 360k on this one as well. That's going to be my final answer for all solutions. So this is all solutions. And that k right there, that's just representing an integer. So if I have that, that can be any integer. So this is just representing is k rotations around. Okay, so that's going to be all solutions. You do need both the 60 and 120. If you just had the 60, for example, and you just had 60 plus 360k, you're never going to get just 120. So you actually need both of those solutions, both of those, like, yeah, solutions, I guess. Okay, let's look at another example here. Let's say we want to solve, let's do the square root of 3 times tangent x is equal to -1. Okay, and we're going to find all solutions again. So the very first thing you want to do when solving trig equations is try to get the trig function completely by itself. So I'm going to try to get rid of the square root of 3 by dividing both sides by root 3. So then I get tangent x is equal to -1 over square root 3. Okay, tangent's by itself, so I can go ahead and draw a picture here. And I want to think about where is tangent negative, because this is a -1 over root 3. Okay, so if I think about my all students take calculus, where tangent's positive is going to be in quadrants 1 and 3. So it's negative in quadrants 2 and 4. So that's where my two angles are going to be. Okay, let's draw my triangles. Okay, tangent is opposite over adjacent. So in my quadrant, or my angle in quadrant 2, opposite side is going to be -1. Well, hold on. The adjacent side is going to be root 3. It's actually the root 3 that's negative because I'm in quadrant 2 here. The hypotenuse then is going to be 2. Same setup for quadrant 4, except the 1 is actually the negative number this time. Root 3 is positive, and that 2 is always going to be positive. So my reference angle right here, it's across from the 1 side, so it's the shorter side. So that's my 30-degree angle. So this is also 30 degrees. Okay, now 30 degrees is not my final answer. I'm going to need this blue obtuse angle. So I can do 180 minus 30. That gives me 150 degrees. And then the other angle I'm going to want is going to be this big green angle. Okay, so the big green angle, I can do 360 minus 30. That's going to give me 330 degrees. So if I want to write all solutions, I'm going to have x is equal to 150 degrees plus 360k, so that's how I get all of my solutions. And then I also need the 330 degrees plus 360k. So anytime you need to find all solutions, you're just going to add plus a 360k or 2 pi k if we're working in radians. Like I guess I could, let me write what the answer would be in radians. Well, let's write it down here, actually. 150 degrees, if you converted that to radians, that is going to be 5 pi over 6. Plus, instead of 360k, I'm going to put 2 pi k. If you converted 330 to radians, that's going to be 11 pi over 6. So then plus 2 pi k. Okay, that would be your solution in radians. Okay, let's look at another kind of example. Sometimes it can look a little bit more complicated. So let's say we have solve cosine squared x plus cosine x equals 0 over the interval 0 to, let's do 2 pi. Okay, one thing I note that now I'm given an interval, so I'm not actually going to have to find all solutions, so I won't need my like plus 2 pi k. I just need the solutions that fall within this interval, which is just one rotation of the circle. Okay, so let's think about how I'm going to solve this guy right here. Okay, first thing I notice is at the moment, it's going to be hard to get like just cosine by itself. If I could try subtracting this cosine x over, that's not really going to help me out a whole lot because I'm going to have still a squared right there. That's not really going to help me very much. So what I can do instead is factor. So sometimes there can be some factoring involved. So just like if you had an x squared plus x equals 0, a way to solve that equation would be to factor. So I'm going to factor out a greatest common factor here, which is going to be cosine. So I'm going to take out a cosine x. When I take cosine x out of cosine squared, I'm just left with a singular cosine. When I take cosine out of cosine, I'm left with 1. And then if you remember from Algebra 1 and Algebra 2, when you're solving by factoring and you have this product which is equal to 0, you're going to set each part equal to 0 and solve. So I'm going to have two equations, cosine x equals 0, cosine x plus 1 equals 0. Okay, so let me deal with this one on the left first. Okay, so where's cosine equal to 0? Now, if cosine is equal to 0, 1, or negative 1, that means it's going to be a quadrantal angle. So it's one of those that's on the axes. So I really just want to figure out where is my x value, because cosine is associated with the x values. Where is x going to be equal to 0? And that happens at 2 spots. So it happens down here on the negative y-axis, because that's going to be a point of 0, negative 1. This is a point of 0, positive 1. Okay, so in both those spots, x is 0, so cosine is 0. Okay, now my answer, because my interval is 0 to 2 pi, that means you should write your answer in radians because the interval is in radians. So let me talk about my 2 radian measures I have here. So this blue one here, it's going to be 90 degrees, which is pi over 2. And then I want this green one, I want the big one. Now, the reason I want to go all the way around instead of just going like a negative 90 degrees is because negative 90 degrees is not within that interval. Okay, this is going to be 3 pi over 2. Okay, so that's 2 of my answers. So I have x equals pi over 2 and 3 pi over 2. Again, I don't need the plus 2 pi k because I don't need all solutions. All right, now let's deal with this guy right here. So the first thing you have to do is subtract that 1. So I'm going to have cosine x equals negative 1. So this is going to be another quadrantal angle. I want to figure out where on the unit circle is the x value going to be negative 1. And if I just think about, a normal coordinate grid, x values are negative over here. So this point would be like your negative 1, 0. That's the only place where the x value is going to be negative 1. So that's my only solution here. And that's going to be pi. So I also have x equals pi from this one. So let's write that all out nice and pretty here. So I just have 3 solutions for this problem.